song for the broken hearted. A silent prayer for faith departed.
I am Muhammad Zikri and I was assigned to do the container box design for this project. And then the requirement for the container is it must be less than 14 centimeter in height, which means we can make it any length as long it didn't touch the sensor and the feeder. And then it can fit 8 ping pong balls inside, which is ping pong balls was standardized for 14 millimeter in diameter for the international standard design for the ping pong ball. And then to make the sensor able to detect, we made this metal quite hard from the box design to be detected by the sensor.
This is the design with complete dimension for our container that we use in project. The total height is 12 cm in height, which is 6 cm for the bottom part and another 6 cm for the upper part. The diameter for the ball to flow through is 5.5 cm with 1.5 cm tolerance. And this box was made by recycled materials such as cardboard box and tin can. Cardboard box was cut to make the bottom part of it, and the tin can was cut to make the upper part of this to allow the ball flow through and for the sheet metal for sensor to detect. Our specialty of this design is the floor design of this container. I have made a decent design with 1.5 cm height in one side and another side have 0 in height, which will allow the ball to flow through. Once it flow through down, it will flow straight away to the front and to the left of the container, and second ball will flow straight down and straight to the front and turn to the right of the container, and the third ball will flow through straight to the front in the middle of the container. The pattern will repeat it for the second row and the third row.
My name is Tan Pihao and I will show the setup as well as the precautions during the project. Okay, so the first apparatus will be our feeder and the sensor attaching on it. The sensor will react when the box goes across and below it. So if our height is enough, then the sensor will light up and the signal will be sent to PLC and then to our Raspberry Pi. To ensure the ping pong ball drops into our box, so actuators or cylinders are used. So when the cylinders can be controlled either manually or electronically, so we can connect this to our Raspberry Pi to control the cylinder. Next, we have our conveyor. So the box will be put on the conveyor and the signal will be also sent from our Raspberry Pi to control the movement of the box. Throughout the project, we have also used 2 switches, black and red, to control either to start the operation or for emergency stop. During our project, PLC is also used as a power supply of 24 volts to our setup. Throughout the project, we have also used this board to prevent the high voltage of 24 volt to enter the Raspberry Pi, as it may damage the Pi. Last, we use our Raspberry Pi as a controller and processor for our project. Next are the precautions during the project. So first, we have to check the pressure value. When connecting the wires on the board, please ensure that you have followed the instructions to ensure the current flow in the project. Throughout the project, we have also realized that the transistor used is of different type from the normal transistors we use, which the first pin will be the base, second pin emitter, and the third pin will be the collector. During the project, we should also make sure that there are no obstructions at the holes in order for the cylinder to be able to outstroke. Connections from the air pump should also be checked for leakage.
Hi, my name is Nazrul Ashraf and I will explain about the wiring connection for the system. So this is the circuit diagram. This is the PLC, valve, relay, sensor, switch and the raspberry pin. For the motor is connected to the two relays which are relay A and B. The function of the relay is to switching on or off and to change the direction of the rotation, whether counterclockwise or clockwise. For the relay, the positive is connected to the 24 volt, the negative terminal is connected to the collector, and GPIO 10 is connected to the base of NPN transistor. The emitter is connected to the ground. For the relay B, the circuit diagram is same like relay A, but the base is connected to the GPIO 7. For the valve, the positive is connected to the 24 volt, the negative is connected to the collector, the base of the NPN transistor is connected to the GPIO 5, and the emitter is connected to the ground. For valve 2, 3 and 4, the circuit diagram is the same, but the base of the NPN transistor for the valve 2 is connected to the GPIO 6, valve 3 connected to the GPIO 13, and for the valve 4 connected to the GPIO 19. For the sensor, the positive terminal is connected to the 24 volt, while for this wire is connected to the GPIO 23 for the sensor A, and the negative terminal is connected to the ground. For the sensor B, this wire is connected to the GPIO 24. Lastly, for the switch A is connected to the positive is connected to the 3V3, while the negative is connected to the GPIO 21, and also the negative terminal is connected to the ground. While for switch B, the negative terminal is connected to the GPIO 20. Thank you.
Hello, my name is Tan Sekir, and now I would like to present the codings of the Mechatronic project.
So now I would like to explain the coding to run the system. So firstly, you can see the first three lines. Is import the code needed for GPIO control, and second import time is for import the code needed for the street functions. So before we start to run the system, firstly we assign the GPIO pin number to variable for the relay, sensor, and cylinder and button. So you can see this RA is relay A. Relay A is equal to 17. It means that the 17 is GPIO pin 17. Relay B is equal to 27. This CY1 is cylinder 1 with the solenoid valve. So 1, 2, 3, 4 is equal to 5, 6, 19, 13 respectively. And SA, SP is equal to sensor A and sensor B with 23 and 24. And red button, black button 21, 20. So now we set up the GPIO set mode. GPIO VCM is use the chip signal number. So now we set the GPIO setup, sensor A, GPIO dot in. So for the sensor and for the button, we use the GPIO in, and for the relay and the solenoid valve, we use the GPIO out. So firstly, we set the initial conditions. So for the first 4, cylinder 1, 2, 3, 4, we make it 1, which means that before we start, all the cylinder is outstroke. and we make the relay A and B is 0, so make it stop. So now we start the process. We put in the while true loop. So if the GPIO input break button equal true, it means that the break button is pressed, the relay A is on, so it will start to move. So we will put another while loop, which is while n less equal to 4. So it means that if the sensor A sense is detected, so the relay A will stop. It will go through inside these 4 loops. So this four actually is dropping one ball. It's only dropping 1 ball. So in our process is drop when the sensor is detected. 2 ball is dropped in 1 times. So this one is only for 1 ball is dropped. So in order to drop 2 times, we use the 4 loops for I equal in the range 2. So when 2 ball is dropped, the relay A is on. It will start to move to the before reach the sensor B. So when the sensor B is detected, the relay A stop again, and the ball will drop again, drop two in 1 times. So after that, after the drop of 2 balls, the relay B will start. When the relay A and the relay B is on together, it will start to move in the reverse directions. So once sensor A and sensor B is go through 1 time, in order to get the 8 balls, so we need to move all the process in 4 times. So we'll make it n equal 0. So it means when n equal to 0, 1, 2, 3, we'll start to move again and again until 8 ball is dropped. When the n equal to 4, the relay A and relay B will stop and the process is done. Thank you.
Hi, my name is Shahir. I'm from Group M8. So in this Mechatronic project, I will explain in detail about the process flow of our material handling system.
So the process I begin by pressing the start button and the conveyor start to move to carry the container and place it under the first feeder. Here, the container is used to collect 2 ping pong balls dropped from the feeder in 1 session. And if you notice, there is a sensor attached to the feeder used to sense the metal part so that the conveyor will immediately stop moving. After collecting the balls, the container is then moved to the next feeder to also collect the ping pong balls. Okay, let me explain how the balls are dropped from the feeder. It is controlled by using the pistons of upper and lower cylinders placed behind the feeder. By using the proper sequence of outstroke and instroke of both pistons, that enables the balls to be dropped from the feeder. Okay, after collecting the balls, you notice the container is moving back to the first feeder. These all motions are actually based on the codes that have been programmed in our Python software. Now here at the first feeder again, the container is collecting the remaining 2 ping pong balls. After collecting, the container is moving back to another feeder to also collecting the last remaining 2 ping pong balls. One has been collected, 1 more to go. Okay, there you go. We have collected all 8 ping pong balls from both feeders by using the container. So here we show to you, we we have collected all 8 ping pong balls in this container. So this is how the process of our material handling system works. So thank you.